aren't a lot of, well, there really are very few rules. It's mostly just using logical common sense. So for example number one, suppose that I said 80% of the people in this class are going to pass with a C or better. That would be pretty good news. Is it reliable though? Well, since I'm the teacher, you would think that I would be telling the truth. One would hope that I wouldn't lie to you. What if I claimed that it was 80.4% of my previous students passed with a C or better? Which of the two sounds more believable? Well, personally, I think that the 80.4% being a decimal sounds like somebody really did the research and had been keeping track for 20 years of how many students they had and how many had passed. To just say 80% of the class is going to pass, I really have no idea where this number is coming from. When in the second statement I say that's what happened with my previous students. So I'm not trying to predict the future there. I'm saying in the past, this is what's happened. That's a fact. With the first one, without any background information, I'm just trying to predict the future. So the second one, talking about 80.4% of the previous students, is more reliable. So here's some true information. This is about Apple Computer Company. Sorry, they're just called Apple Incorporated now. They changed their name. Apple Incorporated. And here's the stock price. So I looked it up, and it went from April 2013 until January 2014. So what's that, about 9 months? It went from $400 to $550. And then look at the little graph that I made. 7 years of art school paid off, huh? So the problem here is if you compare this, if you compare this graph right here and you compare the bigger bar, well, if you compare, it looks to me like this bar right here is about 1/3 the size of this. Or in other words, the January bar is about 3 times bigger. Well, if it was 3 times bigger, then the $400, 3 times bigger, would go to $1,200. So this information right here is basically over-exaggerating how big the price jumped. That the price jumped from here up to there, that would mean that this right here would be about $1,200, which it's not. And so the whole problem is that this scale over here, the vertical scale, did not start at 0. So for these bars to be a better representation of the proportion that the stock price grew, then this scale should start at 0. So I basically started it at 300. This would be 300 right here, and then 4 or 5, etc., when it should have started at 0, 100, 200, 300, 400, etc. Next example, you call somebody's house and ask how much they pay for gas. You know, $3.50 a gallon, how much did you pay? So what's wrong with this? Well, a few things. One is, if you call somebody's house, these days, not a lot of people have house phones. Another thing is, the person may not remember how much they pay for gas, and they might just make up a number. If you were at a gas station and the person was just leaving and you asked them in person, hey, how much did you pay for gas right there when you gassed up? That would be much more reliable. Suppose you have these scores. Is 80 above average? Well, what's meant by average? There is one idea of average that says add those numbers up and divide by 5. So if you add them up, 65 plus 70 plus 78 plus 83 plus 100, and then you divide by 5, it is a 79.2. So is the 80 above that? The answer is yes. But that's not the only type of average. Another type of average is that it's the middle number. So the first one, where I added the 5 numbers up and divided by 5, that's an average. Specifically, that's called the mean. So we got that the mean, which would be x bar, was 79.2. So that's the mean. So if the word average was talking about the mean, then yes, 80 is above that. It could be that we're talking about the median, the middle number, 78. And in that case, well, I guess it is above that also. But I just wanted to point out that the word average actually has a couple of meanings. So finally, we're going to be working with fractions, percents, and decimals. So 2/5, just get a calculator, divide it. And if you divide it, it'll be a 0.4, or you could write it as 0.40. Then as a percent, you just multiply by 100, so that moves the decimal place over by 2. So you just take that decimal and move it over by 2. So number 7, create fractions, the fraction form of 88%. So 88%, literally per cent means per 100, so it's 88 per 100. So that's what this is, the 88 per 100. And then just divide by 4 and divide by 4 to reduce it, and you get 22 over 25. And now fill out the following table. So let's see. Right here, 0.9, if you multiply this by 100, that's going to be 90%. So this one is 90%. And then that means that it would be 90 out of 100. And then you could reduce that. 90 out of 100, well, you could get rid of a 0, get rid of a 0. That's going to be 9 out of 10. And then for 24%, move the decimal to the left by 2, and that would be 0.24. And then likewise, it's going to be 24 over 100. And then reduce that. Which is 6 over 25. Because you could divide by 4 and divide by 4. And then this 1/2 is, of course, 0.50 or 0.5. And that would be 50%. And finally, for 2/3, well, I would like you in this class to use 3 decimal places. So for 3 decimal places, it would be 0.667. And then when you multiply that by 100, it's going to be 66.7%. And that's it.